So today I'll start the first lecture, which is the lecture 1. The name of the lecture is the Introduction to Control System.
Okay, sir.
Okay, the first lecture of this course. Let's move on. Okay, so we are going to start our lecture series. First of all, it is the first chapter from the Simon Ramo. So the first chapter of the Simon Ramo, Introduction to Control System. Introductory chapter, but it is most important one because if you have the idea about the basic control system, then you would understand the remaining topics of this course. That's why this chapter is very important for you. Yeah, so I think I would require 2 classes to finish this one. Minimum 2 classes is required to finish this chapter, Introduction to Control System, the first chapter. Okay, our target is to complete almost 10 chapters, then to 11 chapters. So if we consider that average 2 classes, then we regard 11 into 2 to 22 classes. Average 22 or 24 classes. 2 classes for your presentation and quizzes, other things. Okay, 22 classes for your this one. Okay. Okay, let's move on. Okay, let's talk about the system and control system. So first thing is what is the system? Okay, what do you think? Anyone? Do you have any idea what is the system?
What's that?
System. What is the system? I will explain later, but first of all, I need to know.
The ways are to control something and which have inputs and produces outputs.
Yes, system.
How to produce maybe some product.
Share system. Hello?
Yes, system.
System is a group of interactive or related elements acting according to the set of rules of and follow.
Yes. Okay. So see this picture. What is there? In the first picture, okay. So here, the first figure, this is a system. This block is a system. Here we'll give an input and we'll get output. But the thing is, this output may or may not be desired. Look at this point. This output may or may not be desired. Let's say, if you want as output 5, so you can get the 5 or not. Okay. Let's say if you when what would be the example is okay, let's imagine that in the football ground, okay, you are kicking the penalty ball. In the penalty, what happened? The footballer kick the ball. It may or may not be goal. It may or may not be hit on the goal post. Right? It is not fixed. Maybe the goalkeeper blocked the ball, or maybe he missed and it would be goal. Maybe the footballer or the striker, he would kick the ball over the goal mark. So it is one kind of system. That means the output, okay, he shot the ball, he kicked the ball, but may or may not be desired. Means goal is not fixed. Here comes a control system. Control system is such a system in which you can control the system. As a result, you will get the desired outcome. Let's say when you go to the lift, what you do? You press the button. Let's say you went to the DIU and you went to the lift, press the button, say 6 or 7, let's say 7. Now, when you entered the lift, press the button 7, the lift will go to the 7th floor. That means the library. That means what? You can control the lift, okay, to get the desired output. That is the difference between the system and the control system. So in a control system, you have the sufficient authority to control the system to get the desired output. You understand?
Yes, sir.
The difference is here.
And one time like
So in the control system, you can control the system to get the required output. Okay, to get the required output, you can control the system in the control systems. Okay.
okay, sir.
Okay, that is the difference. I'll explain more. Okay, now see some definitions. Input, the stimulus or excitation applied to the control system. From an other source is known as the input. And the output is the response of the system. And system is what? A system is an arrangement of or a combination of different physical components connected or related in such a manner so as to form an entire unit to attain a certain objective. Okay, it is a collection of a combination of different physical components. Control means what? It means to regulate, direct, command system so that the desired objective is attained. So that you can get out and you can attain the desired objective. It is a control, a regulate, direct, or command. Say that is the control. So system plus control, you'll get the control system. Okay, I think this idea is clear to you, right? What is the control system?
Yes, sir.
Yes, sir.
If you want to control the system, then you have to regulate or direct or command a system to get the desired objective. So the control system rates. Okay, that is the control system. So you can control the system, okay, by using some other objectives, some control parameters, some things. Okay, let's look at a fan. You're familiar with it, right?
Yes, sir.
Yes, sir.
So the fan is running. Now see, so if I think it is a system, what would happen? Say what is the input? Input is the 230 volt, the figures you see, AC supply, right? That is the input. And what you are getting as the output? Airflow.
Airflow.
Understand? So we are giving the voltage supply, okay, or AC supply as an input, and we are getting the output, airflow. The fan, the combination of other things is known as the system. That is the system. Okay. So a fan without blades cannot be a system because it cannot provide a desired proper output, that is airflow. It is obviously true, right? So if you have a fan without the blades, then what would happen? If you apply the AC supply, then this thing will rotate. but you will not get the airflow because there is no blade. Understand?
Yes, sir.
Like this. Let's say you have a fan, something like this. Okay. This thing, right? My drawing is not working, but whatever it is, if you have the fan, but it does not have the blade, then what would happen? It would rotate, right? It would rotate. It will rotate, but you will not get the airflow. So as a result, it is not a system because you are not getting anything. Yes, the main thing is rotating, but it does not provide the airflow. So a fan without blades cannot be a system. Okay, a fan with blades but without regulator can be a system. Okay, see. So this is a system. So if I apply a power supply to the, if I apply the power or voltage to 30 volts 50 hertz AC to the fan, and it will provide the airflow. It will provide the airflow. It is a system, but it cannot be a control system because we cannot control the fan. So we need what? We need the regulator. To control the fan, we need the regulator. So, but it cannot be a control system because it cannot provide desired output, that is the controlled output. So we need what? Now see, that is the control system. A fan with blades and with regulator can be a control system because it can provide a desired output. That is controlled airflow. So which element is the extra here? Anyone answer?
Yes. Yes, sir.
Why it becomes the control system?
Why?
Why we are calling it a control system? Why?
Because it have a control and regulator.
Right. Because it has a control regulator. This one. This one.
Yeah.
For this element or this regulator, we can control by using this one, we can control the fan speed, right? We can control the fan speed. That is why this thing is the control system. See, simple example of control system. The fan, a rotating fan with the regulator is known as a simple example of control system. Why it is control system? Because we are using the regulator here. So we are applying the supply, AC supply, then the regulator. By using the regulator, we can control the fan. Then as a result, we will get the desired output or desired airflow. This is the control system. See, a fan with blades and with a regulator can be a control system because it will provide desired output, that is controlled airflow. Because it can provide a controlled airflow. That is why it is this thing, control system. Okay. So it is clear to you?
Yes, sir.
Okay, so I can go on. Now the definition comes. Control system is an interconnection of components forming a system configuration that will provide a desired system response. Or you can say that a control system consists of subsystems and processes or plans assembled for the purpose of obtaining a desired. Anyone, okay, anyone, I think this one is the most preferable definition. A control system consists of subsystems and processes and plans assembled for the purpose of obtaining a desired output. See, here we are providing the input, here is the process, and here is the output, the desired output. Okay. So a control system consists of subsystems and processes. Subsystem. So you may ask me what is a subsystem here. Let me show you. Let's say here I am putting the input. We can have multiple systems. Maybe you can get the output. That is the input. Say S1, system 1, S2. So a control system consists of subsystems. So subsystems, processes of plans, similar for the part of the computer. So these are the subsystems. See, so it has multiple subsystems, and by combining all, you can get the total control system. So subsystem is there. Subsystem and processes. The combined thing. Maybe based on process. Let's say that is the process. And that is the state. Maybe it could be a control system, right? So this thing. So they say that a control system consists of a subsystem. These are the subsystems. It is a total system. Total is a system, but under the system there are subsystems and processes are plans assembled for the purpose of obtaining a desired output. Assembled for the purpose of obtaining a desired output. So for getting the desired output, we can arrange the things, arrange the system of subsystem in such a way. Okay, let's move on the time. Now see the elevator response characteristics here. So what is happening whenever you push the button, the elevator will lift, go to that place. Now see, here is the interesting thing. Elevator location 4. Elevator response. That is the elevator response. See, it does not come instantly, or it does not move instantly. Rather, it takes some time. Slowly go up, right? It can slowly move up. That is the input command. Say you are giving the input command 4, from 1 to 4. Okay, from 1 to 4. And it requires some time here. 1 to 4 requires some time. After some time, it becomes steady. So here, I use the input command and as this, that steady state position, there is a gap. There is a gap between the steady state response and the input command. This gap, this error is known as the steady state error. See, this error is known as the steady state error. So whenever you push the elevator from 1 to 4, you want to move from the 1 to 4th floor, first floor to 4th floor, then elevator will move up, but it will take some time. Okay, it will not go instantly. This response is known as the transient response. This slow response is known as transient response. Okay, this response is known as transient response, and the steady state response position, steady state position. Then the difference between the input command and the steady state response is known as the steady state error. Which one is the steady state error? Okay. Okay, here this one is the steady state error, right? This gap is the steady state error. Okay, do you understand this so far?
Yes, sir.
Yes, sir.
Okay, that is the steady state error here. Yeah. So that is the steady state error. So that is the transient response, the slow response of the system. And finally, we'll go to the steady state, we'll get the steady state response, and the difference between the input command and the steady state error is known as steady state error. Now, just imagine that whenever you go to the 4th floor, the lift will not be on the level of the floor, little bit lower or little bit higher. That is the error. Generally, little bit lower. So there is a gap. There is a gap between the input and the steady state response. So this gap known as the steady state error. So this is the steady state error. Okay. So you understand this. Okay. So what are the advantages of control system? Like power amplification, we amplify the power. We can remotely control anything. And convenience of input form, compensation for disturbances. These are the advantages of control system. We'll see one by one later. Okay, all things that will come in the form of examples. So what are the advantages of control systems? Some advantages are they're like it can amplify the power. There is a remote control and convenience of input form, compensation for disturbances. Compensation for disturbances. And these are the things. Power amplification, remote control, convenience of input form, compensation for disturbances. Okay, these are the advantages of control system. Okay, so classification of control system. There are several types. Mostly open loop and closed loop. Okay, according to the feedback, you can divide the control system in two types: open loop control system and a closed loop control system, or linear and non-linear, or the time varying or time invariant. These are the types of control systems. So get it. So what is the types of control system? There are several types like open loop and closed loop, linear and non-linear, time varying and time invariant. So these are the several types of control systems. Yeah.
Okay, sir.
Now we'll see the time. See the open loop control system. An open loop control system utilizes an actuating device to control the processor directly without using the feedback. So they use the actuator, they do not have the feedback. In the open loop control system, an open loop control system utilizes an actuating device. It uses the actuating device. It is a device which can actuate the input to control the process directly without using the feedback. To control the process directly without using the feedback. That is the open loop control system. Okay. So in the open loop control system, you have the controller, you have the actuator, you have the process, and you will get out. Desired input response, output, and in the meantime, you have the controller, actuator, and process. Okay, an open loop control system utilizes an actuating device to control the process directly without using the feedback. Okay, that is the open loop control system. Okay, an open
What's the actuator?
Actuator actually a device which can change the input of the system. Okay, it is a device or circuit something. Okay, so the main thing is it does not have any feedback. Directly you push the button, then it will give you the output. Okay.
Okay.
Now see the advantages. What are the advantages here? Simple in construction and design. So it is simple. Easily you can design or make the open loop system. Inexpensive. That means the cheap. It has a faster response. It is easy to maintain. It is generally stable and convenient to use as the output is difficult to measure. Now see, these are the advantages. Some advantages are there, just try to remember. And what are the problem? Disadvantages? High error. Error is high, space error is high. Not immune to the disturbances. See, not immune to disturbance. So if you put the disturbance, so it cannot change the output according to your disturbance. Any change in output cannot be corrected automatically. Right? So these are the advantages and disadvantages of open loop control system. These are the advantages and disadvantages of open loop control systems, right? So what are the advantages? So it is simple in construction and design. It is inexpensive, faster response, easy to maintain, generally stable, convenient to use, and output is difficult to measure. Disadvantage: high stage error, not immune to disturbances, and any changes that cannot be figured out. Now look at some example. Open loop control system example. See here. Bread toaster. Are you familiar with it? Toaster.
Yes, sir.
This machine runs as per adjusted time, irrespective of this toasting is completed. You just give the time. In the meantime, it will toast. But it does not provide if it's occurred correctly or not. So it is the open loop control system example. Another one is electric hand dryer. See, if you put the wet hand under the dryer, then the hot air will come and it will come up to whenever you push the up to certain time, okay, not the whole time. So it is another example of the electric hand dryer is another example of open loop control system. toaster, electric hand dryer. Remember the names. Because in the Viva, sometimes I may ask you about these things. Okay. Two more examples. Automatic washing machine. You set the time. All right, you set the time and it runs according to your timing. It does not measure or it does not check whether the washing is complete or not. That is the loop control system. Another one is the coffee vending machine. I think you're familiar with the coffee machine in the restaurant.
Yes, sir.
These machines also function for pre-adjusted time also. Only it's pre-adjusted time. Okay. So if you remove the cup or mug, it will continue to pour. So these automatic tea coffee vending machine, these machines also function for pre-adjusted time also. Okay, another example, few more examples are there. Right, volume on a stereo system. Volume is adjusted manually irrespective of output volume level. Okay, so you have to manually change the volume. Right, this is another open loop system. Or light switch. Switch C. You have to push the switch to make it on. These are the examples. Okay, so if I am giving you here 6 examples: toaster, electric hand dryer, automatic washing machine, automatic tea coffee vending machine, volume on the stereo system, light switch. These are the example of open loop control system, right? Now the closed loop control system. Closed loop control systems. What you see here. A closed loop control system is a measurement of the output and feedback of this signal to compare with the result. So in the open closed loop control system, there is a feedback. So it will check the output. Then accordingly, it will update. So in the closed loop control system, that is the main difference with the closed loop and open loop, that in the open loop control system, there is no feedback, but in the closed loop control system, there is a feedback. A closed loop control system uses the measurement of the output and feedback of this signal to compare it with the desired input. Reference or command. Okay, so that is the output response. And that is the actual output. So there is this feedback here. So advantages are there. What less sensitive to the noise, and so what are the advantages of closed loop control system? Less sensitive to the noise and disturbances. Say less sensitive to the noise and disturbance. So if the noise or disturbance occur, you do not need to worry about it. Low stickiness error is lower. It is flexible, so you will it higher. Often by simple gain adjustment and sometimes by redesigning the controller. Highly accurate, as any error arising is corrected due to presence of feedback signal. Closed loop control systems are more accurate even in the presence of non-linearity. Non-linearity. We'll come to that point later. And what are the disadvantages? It is complex, expensive, slower response. Feedback leads to oscillatory response. Overall gain is reduced due to presence of feedback. Stability is the major problem, and more care is needed to design a stable closed loop system. See, these are the advantages and disadvantages of the closed loop control system. So you see these advantages and disadvantages. Now move on. What are the examples of closed loop control system? See, automatic electric iron. Electric iron, this is the example of closed loop control system. Electric iron heating elements are controlled by output temperature of the iron. Some examples are there like a missile, autopilot system, CNC machine, computer numeric control lathe machine, missile system, autopilot system. These all are examples of closed loop control system. Industrial robot. See, these are the robots. These are the industrial robots. It can be controlled by the PLC, that is the computer, by the PLC. We can control these robots. These are the example of closed loop control system. Industrial robot, missile, autopilot system, computer numeric control, CNC lathe machine. These are the examples of closed loop control system. Now, what are the difference between the open loop and the closed loop control system? What is the difference between it? Like, the open loop systems are simple and economical. It is simple and economical. The closed loop systems are complex and costlier. And the open loop system consumes less power, it consumes more power. Now, open loop systems are easier to construct because of less number of components required. The closed loop systems are not easy to construct because of the more number of components required. See? And the open loop systems are inaccurate and unreliable. The closed loop systems are accurate and more reliable. All right. The stability is not the major problem in open loop control systems. They are in the open loop system are stable. But stability is the major problem in the closed loop systems, and more care is needed to design a stable closed loop system. And it has a small bandwidth, it is a large bandwidth. Feedback element is absent here. Feedback element is present here. And output measurement is not necessary in the open loop system, and the closed loop control system output measurement is necessary. The change in the output due to external disturbances are not corrected automatically, so they are more sensitive to noise and other disturbances. And here the changes in the output due to external disturbances are corrected automatically, so they are less sensitive to noise and other disturbances. Okay. So this difference is important for your assignment or exam, whatever it is. And I may ask you Viva questions from here also. Okay. Like which consume more power, open loop or closed loop system, and which has a large bandwidth, and what is the main difference? Main difference is the feedback element. Okay, like this. And which one is the more stable? Definitely open loop is stable. Closed loop is not that much stable because it triggers the feedback. Okay. So today I am closing here after this, up to 22 slides. Okay. So the open loop, and so from the next class we will start the time varying and time invariant system.
Okay, sir. Okay, sir.
Okay. Slow. We will start slowly, no problem. Later we can move on. We can speed up.
lab glass.
Okay. So that is the thing. Okay. So that is the open loop and the closed loop system. Now for the laboratory classes, do you have the MATLAB installed in your PC?
No, sir. We have no any constructor of MATLAB.
Oh, you do not have the MATLAB.
Yeah, how that? We have no any.
Do you have the internet connection? Stable internet?
Yes, sir.
Yeah.
Unlimited bandwidth.
Okay. Okay. For that,
You can download, and if you know the how to
yes.
How to install. Yeah.
Okay. I think you know the installation process.
Okay, sir.
Yes, sir.
That's not problem, but sir, we need construct.
Okay. Yes. You need the lab sheet, right?
Yes, sir.
Okay, so I'm providing the lab sheet today, and you check, and from the next week we will start the lab. Okay.
So where will we get the MATLAB?
For MATLAB, you have to check out the torrent.
Torrent.
Yeah, torrent.
Okay.
Do you familiar with the torrent?
Yeah, I know torrent.
Okay, just go to the torrent site and search the MATLAB, then you will get it. But this now lockdown is continuing. Otherwise, I will ask you to go to the campus and collect the tool. But I cannot suggest you right now because there is lockdown. Right.
Okay, sir. Yes.
So you need to download, and I'm providing you the lab sheet. So you check few things, then we will start the MATLAB from the next. Maybe in the meantime, I can take the extra class also.
Okay, sir. Inshallah.
Okay, inshallah.
Allah.
So our next class on the Sunday, right?
Yes, sir.
Sunday, inshallah. So in the meantime, you download the MATLAB and install it on your PC. Then inform me. Then we can proceed.
Okay, sir.
Okay. So let me check the attendance here. Attendance is required. What about your last semester final viva? Who have missed?
Yeah, I missed it in one. Yeah, roll two.
Today is the 22.
Okay.
Okay, roll number 1, 2, 6, 9,
10,
10,
12, 12,
10, 12,
14,
14,
17, 18.
17, 18.
Yes, sir.
1, 2, 3, 5, 9 persons are there.
Yes, sir.
Else
Yes,
I
sir.
take the attendance.
Yes, sir. Thank you.
So 9 persons are there.
Yes, sir.
So I have given you the Google Classroom code. I'm giving the slide here because in the slide I'll add few more things. That's why I have not given yet. But after adding all things, then I will upload. Okay.
Okay, sir. Okay, sir.
Because in the next class we have to finish it.
Okay, sir.
So
Inshallah.
I'll add few more slides here.
Thank you, sir.
That is the reason I have not uploaded it. Okay, so thank you so much for giving time, and happy Ramadan.